What's going on, kids? Hey, do you guys hate chemistry just as much as I do? Well, I'm going to let you in on a little bit of secret. Chemistry is actually pretty rad. It's just super, super, super hard to find a rad chemistry teacher. So I wanted to teach you guys about some of these elements that I'm always talking about with the plants, like oxygen and nitrogen and hydrogen. And I want to show you how things work on more of a molecular level. And I want to teach you guys about what's called a covalent bond, which is just a fancy word for a molecular bond, okay? Now, a molecular bond is when two atoms bond together. So these two little white guys right here are hydrogen. Now, the reason why hydrogen can be so easily bonded, first, it's just a single bond, meaning each one of these hydrogen has its own electron, just one electron. So the negative electron in this guy is attracted to the positive proton in this guy. And the negative electron in this guy is attracted to the positive proton on this guy. So if you look, like it even happens just like a magnet that these are. It's automatically that they just click together right there. It's what they want to do. So how about double bonds, for example? You know, when we have something like oxygen, everybody knows that an oxygen is just simply O2, right? Well, it's not as simple as that as far as it takes a double bond. The reason why it takes a double bond is because of the Octet Rule. Now, the Octet Rule means that electrons like to be shared, okay? So when we break things down, I'll write some stuff on a board for you and it'll make a little bit more sense. But each oxygen atom has 6 available electrons. Well, when we pair these up, you're going to see that there's 2 lonely ones on each one. And when these 2 lonely ones meet up, it creates a double covalent bond. Now, O2 is the oxygen that we breathe in the air, guys. I'm breathing this in right now. But believe it or not, this is not the most prevalent thing that we're breathing. We're actually breathing way more nitrogen than we are oxygen. Nitrogen are these blue little balls. So when nitrogen forms together, it doesn't take a single bond, it doesn't take a double bond, it actually takes a triple bond. And that's because these guys have 5 available electrons. And the way that they pair up, when you're going to see me write this on the board, it'll make a little bit more sense. So here, we take our little bonding tools here. I can figure out how to make it work. Right. Now that is the N2. This is the nitrogen that we're breathing in our bodies right now. Now we could take a similar one, for example. Everybody's heard of CO2, right? You know, that's because we have 2 oxygen molecules and 1 carbon. Now this is created with 2 simple covalent bonds here. So we have this set up, and then we have our extra oxygen set up. That's why that carbon, that little ball's already got 4 places for me, because it knows in that electron, those electrons are never going to change. They only change how they're shared. So let me check something out on a piece of paper for you over here on the board. Now, let's imagine I've got some covalent bond written up here. Now, same thing as a molecular bond. I want to show you guys why these things are thinking the way they do, as far as why they feel the way they do, why they're attracted the way that they are. So let's take oxygen, for example. We have oxygen, and I know that that has 6 electrons. The reason I know that is because you look at an elemental chart and where the elements are, and you'll see that's in column 6, meaning it's got 6 electrons. So we got 2 right here, 2 right here, that's 4, and 1 right here, 1 right here. That's at 6, right? And then we have another oxygen, because we were talking about a double bond, right? I'm going to show you just how easy this is. The problem is a lot of our science teachers and a lot of our chemistry teachers, we're super big nerds, and we can't get out of our own minds long enough to get into yours. So I want to try to peek into your brain a little bit, because this is a little simpler understanding. These are our 2 oxygens that are wanting to bond together, right? Well, the Octet Rule says that electrons like to be paired, and they like to be shared. So these two are singled out. They're not paired, right? So they're going to want to pair with that one. And they're going to want to pair with that one. Now imagine that was that red ball, and these were those black little bonds that I made. So maybe this makes a little bit more sense to you now that you're starting to understand just how we get from a single bond to a double bond or a triple bond. It's not exactly about how much it needs to bond if it's going to be a triple bond. It has to do with how many electrons it has and how it's going to be shared with the other molecules or the other elements to create the molecule. So think about it in this way, guys. I got an interesting idea. This is a single bond. Let's say it's a string, right? Going from point A to point B. Now, a double bond is the same size string, okay? But it's going like this. Double bond. It's twice as strong, but it's twice as short. A triple bond would be that same thing. It's the same length as that one, but it's going like this. That's your triple bond. The triple bond is stronger, but the triple bond is shorter. So it has its cons and it has its pros. I hope that this is a little bit more relatable for you kids, just because I realize when you start even saying the word covalent bond, you already lost my interest. Like, no, this is stupid. And the truth is, it's actually really, really cool. When you get an idea of how stuff works on a molecular and elemental level, it really starts expanding your mind about how these molecules actually start working together. You know, I know that nitrogen, for example, is a key component in that molecule chlorophyll, which is what gives those plants its greenness and what creates cell division and all this good stuff. So understanding how these covalent bonds work, I know that if a plant wants to get a nitrogen molecule, it has to trade one hydrogen. So it has to be able to give up a hydrogen just to make that exchange. Well, if I have an iron deficiency, for example, I know that it might not be as simple as putting iron in the soil. That's because the soil's probably got iron, but the plant's not getting it, right? Well, I know that that plant, to get one iron, or actually that's an Fe, not an I. Better do it right, huh, kids? To get one iron, it has to give up 4 of these hydrogens. Sometimes that's a little bit difficult for a plant to do. So understanding things on a molecular level can give you a greater understanding of just how the whole entire world works.